The first one is overview of broadband wireless technologies, mobile WiMAX high-level architecture.
You may view the disclaimer here in order to review the copyright requirements. Good day, everyone. Today, we're going to study the course of mobile WiMAX. The assumption is that everybody is familiar with the basic WiMAX technology. In any case, in this first session, we'll provide an overview of the broadband wireless technology so everybody can get up to speed with the technology and the basics of it. Then, we're going to study the mobile high-level architecture. We're going to delve into the mobility 5-layer support. And later, we're going to study the mobility MAC layer support, and we'll have a session of the WiMAX end-to-end network architecture. We will then learn how to plan and deploy WiMAX networks. In addition to that, we're going to have a session on voice over IP and a special case study that summarizes most of the topics that will be covered during these sessions. In the first session, as we mentioned, it will be an overview of broadband wireless technologies. We will start with the 802.16 protocol architecture model. As you're able to see, this model in the 802.16 standard paper, the architecture model is combined with the 3 basic layers. First, we see the physical layer, which is the file layer, as we call it, in the middle part. As you can see, the marked common sublayer. At the top of the model, you can see the convergence sublayer, what we call CS. Around this model, on the right side, you can see the management information base, which we use to manage all 3 layers of the model. Altogether, this model is the 802.16 standard defined using the paper that was introduced in 2005. As we're discussing the 5 layers, we have 2 basic types of communication. We have the single carrier communication and the multi-carrier communication, which is basically based on the RF level. A single carrier resembles a faucet whose water springs out at once. At the contrary, a multi-carrier, you'll see a springing out of water spreading an amount from multiple streams out of the same faucet. Same amount of water will come out in both. Basically speaking, both information is carried this way and received this way from the top all the way to the client. One of 2 models. Another way of describing this model in the way that is reflected is a truck. A truck that carries all the luggage that needs to be shipped from point A to point B. Or multiple trucks that take the same amount of luggage in a different time or a different way. If you want to look at the real world, the one we're dealing with, you would say that the single carrier is a single frequency that carries information. And you have, on the other hand, 2 or 3 more carriers that are divided, widespread, and are far enough from one another so that they can carry information from point A to point B at a multiple pace. At the contrary, the older technology reflects a different way where a multiple carrier piles up the information, sends them all using a single radio or single frequency band from the transmitting radio to the receiving radio. If you want to look at it in a different way, more detailed way, we can say that one carrier can take, for example, the blue carrier carries information, the green carrier, which is very close by frequency, in a way, is the null path of the blue carrier and is exactly aligned with the top of the energy from the green carrier. Same takers to the red carrier, which is exactly aligned to the null of the green carrier and takes all the information on the top part of the red carrier, and the information is modulated so that N, for instance, is a signal. If you look at the channel response in the time domain, we can see a multiple wings, multiple energy tops that goes in the time scale of 0 through 10. You can see 5 pauses, and you have a purple line that sums them up by energy. The energy that is transmitted or passed is the same supporting time, If we move just